In this video, we're going to cover section 3.7 on the elasticity of demand. So this is a term we use in the business world to decide whether or not raising the price of an item is a good idea or not based on the demand and what that will do to the revenue. So our objectives for this section are to find the elasticity of a demand function, find the maximum of a total revenue function using the elasticity, and then characterize demand in terms of elasticity. So the value of elasticity tells you whether you're at a maximum or if raising the price would hurt your revenue or if raising the price would help your revenue. All right, so the definition, the elasticity of demand, we'll call this a function of x defined by the letter capital E, is given as a function of the variable x, which represents price. So the elasticity function as a function of price equals, notice there's a negative sign right here in front, so the negative of x times the derivative of your demand function divided by the demand function. So you're given a demand function, you find its derivative multiplied by x, put a negative out here in the front, and then divide by the original function. So that's how you calculate the elasticity function. All right, so the value of that function E, how it relates to the value of 1, will tell you something about the values of x. So total and your total revenue. So total revenue is increasing at the values of x for which the elasticity function is less than 1. So when your elasticity value is less than 1, then revenue is increasing. So in other words, raising the price by a small amount, right, will increase the revenue. Total revenue is decreasing at values of x for which your elasticity function is greater than 1. So if revenue is decreasing when elasticity is greater than 1, increasing the price under that situation is not going to be helpful. And then total revenue is maximized at the values of x for which the elasticity is equal to 1. So that's what you want. You want to find the value of x for which the elasticity value equals 1 to know when you are maximizing your total revenue. All right, so let's look at this first example. So we're going to look at elasticity of demand for a video game rental application. So the demand for video games rentals at Klix Video Games is given by this function, Q, which is your demand function, d of x equals 120 minus 20x, where Q is the number of video games rented per day at x dollars. Find the elasticity of demand as a function of x. Then find the elasticity when x values are 2 and 5, interpret the meaning of those. And then find the value of x for which the elasticity value equals 1, and what does that mean? All right, so here's our demand function. Part A says find the elasticities. We're using our definition of that formula. So we're going to first find d prime. So looking at our given demand function, the derivative is negative 20. So our elasticity function said that elasticity equals negative x times the derivative of demand divided by the demand. So negative x, the derivative value we said was negative 20, and then this was the original function. That goes on the bottom. We're just going to clean that up a little bit. So this negative times this negative makes a positive, so that numerator becomes positive 20x. On the bottom, we can factor out 20, leaving 6 minus x. And then I can cancel the 20s, simplifying to x divided by 6 minus x. All right, so part B was to evaluate the elasticity function for given values. So when it said to evaluate when x is 2, so I take my result that I got, x divided by 6 minus x, plug in 2 for x. So I get, this would be 2 divided by 4, which is a half. So that means at x equals 2, that's what I plugged in for x, the elasticity is less than 1, right? That the value I got was less than 1. Therefore, a small percent increase in price will cause an even smaller percentage decrease in quantity demanded. So therefore, we would say that our demand is inelastic, not elastic. Raising the price of each rental by a small amount will increase total revenue. So when the value of elasticity is less than 1, a small amount of increase in price will increase your revenue. All right, then it said calculate when E was 5, or when the X value was 5, calculate E. So 5 divided by 6 minus 5 just gives me 5. All right, that value is greater than 1. Therefore, a small percentage increase in price will cause a large percentage decrease in your demand. So in this case, we would say that our demand is elastic. So it's elastic when the value is greater than 1. It's inelastic when the value of E is less than 1. So when it's elastic, raising the price of each rental by a small amount will decrease your total revenue. In other words, not as many people are going to buy it. All right, and then part C was to find the value for when it equals 1. So if I set the E function that I ended up with earlier equal to 1 and solve for x. So my E function simplified to x over 6 minus x. We're going to set that equal to 1. So if I multiply both sides by 6 minus x, I get x equals 6 minus x. And then add x to both sides right here. Add this over to the other side, gives me 2x equals 6. And then dividing by 2 would give me x equals 3. So what does that mean? This means that this is the price that results in unit elasticity, meaning when the elasticity value equals 1. So that means at $3 per rental, they're going to maximize their total revenue. So the demand was 120 minus 20x. So if I plug in 3, we would get 60. So the demand would be 60 rentals a day. And then the revenue, if those were sold, would be 3 times 60 or $180 a day, right? 3 meaning your price. And that's the best scenario. Okay, so let's try another one. So this one, if you want to write this down and try it on your own using the last example, and then so pause the video, try to do it, and then you can pick up and play the video to check to see if you've gotten your answer correct. All right, so the demand for organic chewing gum is given by D or Q of x, or Q equals your demand function, D of x equals 35 minus 7x, where Q is the number of packs sold per day at X dollars per pack. Remember, X is price. Find the quantity demanded when price per pack is $2, $3, or 5. So that's just simply plugging in 2, 3, and 5 into the D function. Find the elasticity of demand as a function of x. That's our negative x times d prime over d. And then find elasticity at x equals 2, 3, and 5 and interpret the meaning of those values. All right, so to find quantity demanded, you just simply are going to plug in those values of x that were given. So when it is sold for $2 a pack, your demand function was 35 minus 7x. So if I plug a 2 into that, we would get 35 minus 7 times 2 is 14, so 21. So if it's $2 a pack, the demand is 21 packs a day. When it's $3 a pack, I plug in 3 into my demand function and get 14 packs a day, so they sell less when the price goes up. And then when it's $5 a pack, the demand is 0. So note here that the price at $5 a pack, there is no demand for the chewing gum. Right there, it's just too expensive. People are not going to buy it. All right, to find the elasticity, we first need to find your derivative, which would be negative 7. Then your formula, negative x times d prime over d. So negative x times the negative 7 divided by the original function d. Clean that up, gives you 7x, and then on the bottom you could factor out 7. So the 7s would cancel, leaving x over 5 minus x. So then it said evaluate at 2. So when I plug in a 2 to that elasticity function, I get 2/3. So at $2 a pack, the value of elasticity is less than 1. Therefore, a small percentage increase in price will cause an even smaller percentage decrease in quantity demanded. Therefore, it is inelastic when it's less than 1. So raising the price of each pack by a small amount will increase your revenue. When you plug 3 in to your elasticity function, you get 1. So that means at $3 a pack, you achieve unit elasticity, meaning at $3 a pack, you maximize total revenue. And then at $5 a pack, notice elasticity is undefined. Or I'm sorry, evaluating at $5 a pack. Your elasticity is undefined, meaning, remember that was where we got the demand was 0. So here it's undefined. So remember, if there was no demand at that price, the elasticity is undefined, since increasing the price cannot lower the demand any further, right? Because it can't be less than 0, nor can revenue be decreased by raising your price, because you don't have any revenue in the first place. So anytime that your demand is 0, you're going to get undefined elasticity. All right, so that's basically it for this section. For any demand function given, the elasticity function is given by that formula, -x times d prime over d. Demand is considered inelastic when the value of E is less than 1. That means small increase in price, revenue increases. The demand is elastic when the elasticity is greater than 1, meaning a small increase in price will decrease revenue. And it would have unit elasticity when the value of E is equal to 1, and at that price, you have maximum revenue. All right, so that is the end of section 3.7.